Let's talk about example 5 where we left off yesterday. Remember, when we are proving an identity, our job is to prove that the left equals the right, yes? Traditionally speaking, we start with the left. So cotangent squared u over 1 plus cosecant u. And our job is to hopefully show that that equals cotangent u times secant u minus tan u. All right, I'm not good tonight. I think this one is going to be a tougher one. Okay, I feel like this one is a tougher one just to, I don't know, see where to go with it.
For the top, can you make it 1 minus? Wait, okay, 1 minus cosecant squared u?
You can. And what brings you that to mind?
Pythagorean identity.
Okay, so that's a Pythagorean identity. And does that have some similar pieces to our denominator?
Yeah.
Okay, and that's because otherwise it seems like a weird thing that would be going from a single term to something added or subtracted. But that is the first step I have. Okay, and again, I'm never going to say it's the only step because there may definitely be other stuff. But so cotangent squared u, Pythagorean identity, right? Says 1 plus cotangent squared u is equal to cosecant squared u. And so if we subtract 1, then we have cotangent squared u is equal to cosecant squared u minus 1. Okay, so now it's still over 1 plus cosecant u.
Can you get rid of the denominator?
You cannot. Okay, so, and I don't know which ones we've clarified and not, but common mistake here is to say, okay, I'm going to cancel a cosecant with a cosecant, and I'm going to divide the ones, but it doesn't work that way. Because in order to cancel, we have to cancel a factor with a factor. And so when you have adding and subtracting pieces, we can't divide or cancel just piece by piece. Okay.
Can you get rid of the denominator by multiplying by reciprocal?
You don't mean reciprocal, you mean conjugate.
Conjugate, yes.
Okay. So I see the idea of multiplying by conjugate. There's actually a better way to go here in terms of, look at that numerator. Okay, that numerator is currently cosecant squared u minus 1. It's of the form x squared minus 1.
So cosecant minus 1 plus 1.
Yeah. X squared minus 1 is difference of squares, right? That means difference of squares factors into x plus 1, x minus 1. Except ours aren't x's. What are they? They're cosecant u's. So thus, this is difference of squares in the numerator. 2 parentheses. Cosecant squared u breaks into cosecant u times cosecant u. Square root of 1 is 1. Multiplying by negative 1 is plus and minus. All over 1 plus cosecant u.
Can you cancel the 1?
Okay. So on top we have a factor of cosecant u plus 1. In the denominator we have a 1 plus cosecant u. Those are equivalent pieces. And so yes, we can do a cancel. Cosecant u plus 1 cancels with cosecant u plus 1, leaving us with cosecant u minus 1.
Do you want to break it 1 over sine?
Okay, and that's the kind of situation we've hit, it's like we've got it almost too simplified, if that makes sense. Because our job is to show that it somehow circles around to this cotangent u times secant u minus tangent u. So my suggestion would be, okay, let's work in terms of sines and cosines. Okay. Because, you know, once we're in terms of sines and cosines, we can finagle stuff till we get to what we need here. So we know cosecant is the reciprocal of sine, and so it's 1 over sine. The other piece I have of this, so I'm going to do something else in the same step. So cosecant of u is 1 over sine u. We've got, I mean, at that point, you're going to have 1 over sine u minus 1. Still not a lot to do with that. Okay. How can I rewrite 1 so it has a common denominator with the first fraction? Okay, so my first fraction has a denominator of sine. What is 1 in terms of sine? Well, 1 can have any denominator at once, right? It's just itself over itself. So sine u over sine u. The whole point of getting a common denominator is you can put the fractions together, add or subtract. So in this case, common denominator is sine u. Numerator is 1 minus sine u. Okay. Again, we still kind of have a long way to go, it looks like, right? So let's start, as I kind of look at the end and kind of think backwards here. Let's look at this cotangent for a moment. What do you know about cotangent?
Cosine over sine.
It's cosine over sine, yes? In this problem, I have a sine in the denominator, yes? But what I don't have is I don't have a cosine in the numerator. Okay? So what my suggestion is going to be here is that we multiply the cosine in. Now, how can I legally do that? If you multiply the numerator by cosine u, multiply the denominator by cosine u. Because remember, realize, when I'm multiplying by cosine u over cosine u, I'm just multiplying by 1. Multiplying by 1 does not change the value of it. Multiplying by this form of 1 changes the look of it, but it doesn't change the value of it. So, as I rewrite this, I'm going to put my cosine u out front on top. So it's cosine u times parenthesis 1 minus sine u. Because I'm trying to get somewhere, well, sine u times cosine u, I'm going to keep the sine u first and the cosine u second.
Do you want to distribute the cosine u?
No. Okay. Sorry. Good question. As I said, I told you guys, this is a tough one to see because you really just kind of have to kind of pull stuff out of the air and make it happen, which makes it tougher to see and do.
You want to multiply by the reciprocal or conjugate? I don't know.
Okay. So what I tried to set up on purpose is that it's cosine u times 1 minus sine u. It's sine u times cosine u. What do you see right here? Cosine u over sine u can eventually become cotangent when I'm ready to go there, yes?
Yes.
Okay. Now, the reason I did that, and I'm not going to change it quite yet, but know in our brains, you can change it if you want, know in our brains we have our cotangent right there, don't we? Now, this other piece, I'm going to make a fraction. It's 1 minus sine u over cosine u. Okay, are you okay with what I did here?
Yeah.
Because if I multiplied these back together, does it equal that previous step?
Yeah.
And it does. Now, cosine u over sine u, it is cotangent. I'm going to go one more step before I make it cotangent. One of our options, when we see two fractions being added or subtracted, is to get a common denominator and add. Another option is when we have a fraction that's already added or subtracted together to pull it apart. How can I pull this second fraction apart? It's 1 minus sine u over cosine u. When I say pull it apart, what is that? Do you know what I'm...
1 over cosine and then negative sine.
Okay. Both pieces in the numerator go over cosine. And so what I'm looking at here is that I can break this into 1 over cosine u minus sine u over cosine u. Do you see what I did there? And think backwards if it helps, because that's the thing. We're kind of working the opposite direction of what, we're not used to breaking a fraction up. But if we took 1 over cosine minus sine over cosine, there's a common denominator, right? You subtract them, it'd be 1 minus sine over cosine. Do you see it?
Yeah. Yeah.
What is cosine over sine? That is cotangent. We already talked about that. I could have changed it several steps ago. I just was leaving everything for the moment. Parentheses. What is 1 over cosine? Secant. Minus. What is sine over cosine? Tangent. What just happened?
Got it.
We're there, aren't we? Did I even have to write that step in right there since I already had the end written?
No.
No. But we're there, folks. Everything matches. We made some magic happen, right? Okay. Now, I will say, I don't feel, from my perspective, you guys are going to look at some of the homework problems and think they are all just as hard. You're going to be looking at them and think, oh, that's just like number 5. I don't feel like most of them are like that. I don't feel like it's like this to the extent where I feel like you're kind of having to create things to make things happen. Okay? I feel like the others are better representations of, more the ones that you'll follow along in homework. Okay? But it's all manipulating the situation, okay? Now, homework. I want you to look at it. You'll have some time in class today, but make sure you look at every single problem. Try every single problem. It's 12 through 39, multiples of 3. We talked at the end of class today, if you prefer the written out numbers, there's 10 of them, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39. If the problem number is not divided by 3, don't do it. Okay? I will be grading these after we're done tomorrow. Okay? So your job is to prove to me, make me believe that the left equals the right. The beginning equals the end. Okay?
Okay.
We will spend tomorrow going over some questions. So come well prepared, right?
Mm-hmm.